Let's kick things off with a massive question. What is everything actually made of? I mean, your desk, the air, the stars. What's the one thing that connects them all? Well, we're about to find out. Let's dive in.
No, really, take a second. What on earth could possibly connect you, a living, breathing person, the solid phone in your hand, and the totally invisible air all around us? They seem like they're from different worlds, right? But it turns out they all share one incredible fundamental secret. And that secret is, they're all made of matter. It's actually a pretty simple idea. Scientists have a name for all the stuff in the universe, and that name is matter. The rule is simple. If it has mass and it takes up space, has volume, then it's matter. So your book, a cloud, even a single tiny grain of sand, yep, all of it is matter.
Okay, but that just opens up an even bigger question, doesn't it? What is this matter itself made of? For the longest time, this was a huge debate among scientists. So let's investigate this tiny little secret together.
Here's what they were arguing about. One group thought matter was totally smooth and continuous, like a solid block of wood with no gaps. The other group was convinced it was made of tiny, separate little bits, kind of like a beach is made of zillions of grains of sand. So who was right? Let's find out with a quick thought experiment.
All right, get this image in your head. You've got a glass of water, and you take a marker and draw a line right at the water level. Got it? Okay, now imagine taking a spoonful of salt, dumping it in, and stirring until it all just dissolves.
So the salt is gone, right? Poof, vanished. But here's the crazy part. You look at that line you drew on the glass, and the water level hasn't moved. Not even a little bit. How is that possible? If the salt is still in there, where did it go?
Aha! And there it is. This is our proof. The water isn't one solid thing at all. It's made of countless tiny water particles, and here's the key. There are little empty spaces between all of them. The even tinier salt particles just slipped right into those gaps. This is how we know for sure that matter is made of particles.
So, just how small are we talking? Well, as the source material puts it so perfectly, they are small beyond our imagination. To give you an idea, in some experiments, just 2 or 3 tiny crystals of a chemical can color a huge amount of water. That means one single crystal must hold millions upon millions of these microscopic particles. It's truly mind-boggling. So, we've figured out that everything is made of these unbelievably tiny particles. Now, let's get into the secret rules that tell us how these particles act. It really all comes down to 3 big ones. Okay, you ready? Here are the 3 golden rules for every particle in the universe. First, like we saw with the salt and water, they have spaces between them. Second, they are never, ever still. They are always moving. And third, they attract each other, almost like tiny magnets. These 3 rules, they pretty much explain the entire physical world around us.
That's right. Particles are constantly wiggling, vibrating, and zipping around. This energy of motion is called kinetic energy. Think about it. Why can you smell hot food from across the room? It's because the heat gives the food's particles a ton of kinetic energy. They move way faster and travel through the air to reach your nose. Cold food? Not so much. Its particles are moving much more slowly.
There's actually a scientific name for this natural mixing process. It's called diffusion. It's just what happens when particles spread out and mix together all on their own. If you put a single drop of ink into a glass of water, you don't even have to stir it. The ink particles and water particles are moving around so much, they'll just mix themselves up. That's diffusion in action.
And that brings us to rule number 3. Particles attract each other. I love this image of the dancers because it's the perfect way to think about it. Imagine some particles are like the dancers locking arms. That's a super strong force of attraction, really hard to pull apart. Others are just kind of holding hands, a weaker force. The strength of this attraction between particles is the key to, pretty much everything. So let's put it all together. These 3 rules, the spaces, the constant movement, and the force of attraction, are the exact reasons why we have the 3 states of matter we see every day: solids, liquids, and gases. This chart breaks it all down perfectly. In a solid, that attraction force is super, super strong, like our dancers locking arms. The particles are packed in tight and just vibrate in place. That's why a solid has its own definite shape. Now, in a liquid, the attraction is weaker. The particles are still close, but they can slide and glide past one another. That's why liquid takes the shape of whatever container you pour it into.
And a gas? Forget about it. The attraction is practically zero, and the particles have so much energy, they're just zooming all over the place, super far apart. This is why a gas will fill up any room you put it in, and why it's so easy to compress.
So, if the state of matter just depends on how the particles are moving and attracting each other, does that mean we can change it? You bet we can. And the secret ingredient is energy.
It really is that simple. When you add energy, like heat, you're giving the particles more kinetic energy. They start moving faster and faster until they can overcome the forces holding them together. And if you take energy away, they slow down, and those forces of attraction can grab hold and pull them back together again.
And of course, we have names for all these changes. When you add heat to a solid, its particles break free and it melts into a liquid. Add even more heat, they break away completely and it boils into a gas. Then you can go the other way. Take heat away from a gas, it condenses back into a liquid. Take away more heat, and that liquid freezes into a solid. It's a never-ending cycle.
But wait, get this. There's a cool shortcut. Some materials can do what we're calling a superskip. They can jump straight from a solid to a gas, completely skipping the liquid phase. That's called sublimation. And the reverse, going directly from a gas to a solid, is called deposition. It's a pretty cool exception to the rule.
And there you have it. The next time you look around, you can see the world in a whole new way. It's not just a bunch of stuff. It's an incredible, dynamic dance of trillions and trillions of tiny particles, all constantly moving, interacting, and changing based on how much energy they have.
So, to wrap it all up, here's one last question to see if you've got it. We just learned that changing a liquid to a gas, that's evaporation, requires energy. So with that in mind, why does sweating on a hot day actually make you feel cooler? The answer is right there in the science we just covered. Think about it. Thanks for joining me on this deep dive.